Good morning, grade 8s. I just wanted to take up the problems with you. So the first question was pretty straightforward. What you needed to do for this one was you had to try to find the distance. So if you notice here with the question, what you have to do is manipulate the formula so that you are solving for distance. So that ends up being distance is equal to speed times time. And the only really issue with these ones is there's just a lot of, it's a big numbers, right? So what I did was I used the speed of light, and then I converted the 365 days to seconds, and that's how many meters I got. You may have had a different unit in your answer, so your number might be slightly different. Okay, number 2, similar type of question. You're trying to solve for the distance again. What I did here was I converted the minutes to seconds, and then I multiplied it out, and that was the answer that I got, either in meters or kilometers. For number 3, I'm just going to turn here. Number 3 is a question about motion. We're looking for the average speed and the average velocity. So if we do the average speed, the individual walked 4 meters east, 2 meters south, 4 meters west, and finally 2 meters north. Added those all together and then divided by 24 seconds, and that was the answer that I got for speed. Now, theoretically, we know the velocity is equal to displacement over time. Since he went back to his starting point, then that would actually be 0. So if you divide 0 divided by 24, then you shouldn't technically have a velocity. Number 4, what you are trying to solve for here is time. Notice how I manipulated the formula so that time is now equal to distance over speed or displacement over velocity. In this case here, it actually ends up being the same thing. I converted kilometers, 500 kilometers to meters, divided by 700, and I ended up with 714.3 seconds. Okay, number 5, from what I saw from you guys who sent them in, was a bit of an issue, and you weren't maybe exactly sure what I was looking for. So first of all, you were just going to be looking and like sketching a graph. So if you take a look at the first one, the distance graph. So notice, all right, it says in the question that the individual takes the elevator up the CN Tower and she goes to the main deck 346 meters in 15 seconds. So that would be that line there, right, going up the elevator. Then she stays on the main deck for 10 seconds, which means she's not moving. Then she goes up to the sky pod. I don't know if you guys have ever done that before. It's actually a little bit further up. So that would be represented here. And then she stays at the sky pod for a certain amount of time as well. Now, because distance is not a vector quantity, we're looking at total distance traveled. So total distance travel would actually be all the way up to the CN Tower, to the very top, and then all the way back down. So if you look at my last line, notice how the line is going to go up because that's the total distance that the person traveled. And if you see here, I just remember total distance traveled. Here, if you calculate the changes in the lines, that's what you should have gotten roughly. And in this case here, speed and velocity are actually going to be the same thing. All right, now the displacement time graph. If you take a look, it looks very similar to the distance time graph. You're going up the elevator, you're staying at the main deck, that's the flat line, going back up the elevator, going to the flat line of the sky pod, and then you're going all the way back down. But this time, because now the two opposite directions would be up and down, so you end up with a negative slope. Now if you take a look here, I wrote this down, in a displacement graph, a change in direction is a negative slope. So you could have actually, if you go back up here, and if you look, the first two answers are going to be the same. You could actually, for sky to ground, you could either have what I wrote, 39.5 meters per second down, or negative 39.5 meters per second up. Because remember, with a negative slope, it's always going to be the opposite direction. All right, Hope you guys are doing well, and I will talk to you soon. Take care.